Hi everyone! In the first video, we talked about frameworks of reference for interpreting test scores. In this video, we will discuss how to explain assessment results from descriptive statistics, which is mainly concerned with summarizing data. Firstly, I will introduce very basic concepts of frequency distribution, which are frequency, proportion, and percentage. Frequency refers to how often a score occurs in a set of scores. In other words, how many students get a particular score. If you have a small set of scores, you can manually count how many times a score appears. For example, if you have 25 students taking a test, after giving them scores, you can calculate how many students get 0, how many of them get 5, how many of them get 8, how many of them get 10, and so on. The result you get is the frequency of the scores. You can put them all in a table with a column for listing scores and a column for their corresponding frequency. If you have a large set of data, you will need to enter your data in Excel, for example, and then use certain functions and tools to get the frequency report as you want. You will learn how to do this when I show you how to draw histogram in Excel later. The second concept I want to introduce to you is proportion. Proportion refers to the proportion of students who had a certain score, which is calculated by having frequency divided by the total number of students. For example, there are 5 students scoring 9 on a test, and you have a total of 25 students. Then the proportion of the score 9 is 5 divided by 25, which is 0.2. Another concept to mention is percentage. Percentage refers to the percentage of students who had a certain score, and we can calculate this by having proportion multiplied by 100. Continue with the previous example, we have 0.2 as the proportion. To get the percentage, we multiply 0.2 with 100, then having 20%. That means 20% of students in the class get the score 9 on the test. Frequency distributions are often presented with graphs and charts. We will discuss 4 types here: bar charts, pie charts, histograms, and frequency polygons. The first 2, bar charts and pie charts, are used with categorical data, which involves sorting a large group into smaller groups, not based on numbers, for example, males and females. Whereas the last 2, histograms and frequency polygons, are used with numeric data, which involves data with equal intervals between points on the scale. I will show you how to draw histograms in Excel. Step 1. Let's open Microsoft Excel. Step 2. You have to enter your data in a column, and in a different column, enter suitable bin range, that is, all possible scores for the tests. For example, from 0, 1, 2, 3 to 10, or from 0, 10, 20 to 100, depending on your test. Step 3. On the menu, click on the Data tab and select Data Analysis. Next, you select the histogram option and click OK. Another window opens. In step 5, you select the input range. This is your data. Then select the bin range. Step 6. You choose the new worksheet and check the chart output box. Step 7. You click OK. Then you can see the new worksheets with the histogram and the frequency reported for each particular score as well. And now, we will talk more about characteristics of frequency distribution, which evolves from central tendency and variability. First, about the forms of frequency distribution. The symmetry of a frequency distribution is a comparison of the left and right sides of the distribution. If you make a vertical fold in the center of the distribution, and you see that the left side and the right side of that frequency distribution are mirror images of one another, we say that the distribution has symmetry, or the distribution is symmetrical. In a perfectly symmetrical distribution, the mean, the mode, and the median are equal. However, distributions in real life are rarely exactly symmetrical. Therefore, if a distribution is close to being symmetrical, we may still label it as symmetrical. If a distribution is not symmetrical, it is said to be skewed. In a skewed distribution, most of the observations are piled up on one side, with many fewer on the other side. The side with fewer observations has been referred to as a tail. If most of the scores are on the left side and a tail forms to the right, the distribution is said to be positively skewed. If most of the scores are on the right and a tail forms to the left, the distribution is said to be negatively skewed. In a classroom test, if most of the scores are on the left and a tail forms to the right, that means your test is difficult to your students and most of the students got low grades. In contrast, if most of the scores are on the right and a tail forms to the left, that means your test is easy to your students and most of the students got high grades. Another characteristic of frequency distribution is central tendency, in which we often care most about the mean, the mode, and the median. Let's start with the mode. It is the score that occurs most often. A score set can have more than one mode. This is the least stable measure that often varies in different samples. These concepts can also be used with categorical data. Another measure of central tendency is the median. It is the middle score in a set of ranked scores. In other words, 50% of the scores are above the median and 50% are below it. The median is more stable than the mode. It is not much affected by the extreme scores, so it is more representative than the mean in skew distributions. Lastly, the mean is the average of all the score, or in other words, the balancing point of a distribution. This is the most stable measure, especially in large samples. So it is the preferred measure of central tendencies. Moreover, the mean is the most suitable for relatively symmetrical distributions. In Excel, we can get the mode, the median, the mean with the functions mode, median, and average. Lastly, we come to the variability, which is normally concerned with the range, deviations, variance, and the standard deviation. The first concept to mention is the range, which is the distance from the highest score to the lowest score. Secondly, deviations are based on the distance between each score to the mean. Deviation can have negative value when the scores are below the mean. Thirdly, the variance is the mean of the square deviations from the mean. And finally, the standard deviation is the square root of the mean of the squared deviations from the mean. The standard deviation is a very good measure of spread. A large standard deviation represents a set of scores that are more spread out, whereas a smaller standard deviation represents a set of scores that are less spread out. For example, you have two tests with a possible range of scores from 0 to 10. The standard deviation for the first test is 0.5 and for the second test is 2. It means the scores of the second test spread out more widely than those of the first. You can see the graphic demonstration in the slide to see the difference in distribution form with small and large standard deviations. When working with Excel, you can get most of the above-mentioned measures of central tendency and variability. That is, the mean, mode, median, the range, variance, and the standard deviation at the same time. First, you choose the Data tab on the menu. Then click on Data Analysis, select Descriptive Statistics, and select the input area. After that, locate the output area and click OK. In general, all the descriptive statistics presented above are to help you have an overall picture of the student's performance on the test. We hope you will find them useful. Detailed steps with demonstrations can be found in the slides. This is the end of the video. Thank you very much for watching. Goodbye.